Good day everyone, we are Group Cybergenesis, and today we will present Arduino Project 8 Vibration Sensor. Our group members are Nanjay Nashtiglaw, our leader, myself, Marcia Marpontillo, and Jan Michael Pajeda. This project is presented to our professor, Dr. Earl Marquez Albina, for our subject Application Development and Emerging Technologies. In Arduino Project 8 Vibration Sensor, we use the touch sensor from the Arduino starter kit. This sensor detects basic motion and orientation. Inside, it contains two contacts and a small metal ball. When tilted at a certain angle, the ball bridges the contacts, completing the circuit. For this project, we connected an LED to show when motion is detected. When the touch sensor is activated, the LED turns on. When there is no movement, the LED stays off. This activity demonstrates how motion sensors can be applied in real-world systems such as alarms, safety devices, and motion-activated switches. The material we used for this activity are the following. First, Arduino Uno board serves as the microcontroller. Second, breadboard used to assemble the circuit. Third, jumper bars for connecting all components. Fourth, touch sensor detects motion and orientation. 5. LED act as a visual indicator. And lastly, resistor limits the current going to the LED to prevent damage. So with these components, we successfully built a vibration sensor circuit that reacts to movement.
Today, we'll be explaining our Arduino project, a vibration sensor system that detects movement or vibration and lights up an LED when triggered. Let's start with the first line. In sensor LED equals 13. This creates a variable called sensor LED and assigns it the value 13. This means our LED is connected to digital pin 13. Next, we have in sensor input equals 3. This sets the variable sensor input to pin 3 where vibration sensor is connected. Pin 3 is also to link to interrupt number 1 on the Arduino. Then we have unsigned car state equals 0. This creates a variable called state that will store the number of times the sensor detects vibration. starts at 0. Now we move on to the setup function, void setup. This part runs only once when the Arduino starts. Inside setup, we have pin mode sensor LED output. This sets the LED pin as an output so it can turn the LED on or off. Next is pin mode sensor input. This sets the sensor pin as an input so it can receive signals from the vibration sensor. Then we have serial that begin with the value of 9600. This starts the serial communication at 9600 bits per second, so we can send data to the serial monitor. Finally, we have attach interrupt 1 blink rising. This tells the Arduino to watch interrupt number 1, which is pin 3, and run the blink function whenever a rising signal is detected from the sensor. And then we close the setup with closing curly bracket. Next is the loop function, void loop. This is the part of the code that runs continuously. Inside the loop, we have an if statement. If state is not equal to 0. This checks if the state variable is not 0, meaning the sensor has detected vibration. If vibration is detected, we set state equals 0 to reset it. Then turn the LED on with digital write sensor LED high. We also print the value of state to the serial monitor using serial.println state. And then wait for 500 milliseconds with delay, value 500. If no vibration is detected, the else statement runs. This turns the LED off with digital write sensor LED low and prints the value of state to the serial monitor. Lastly, we have the void blink function. This is the interrupt function that runs whenever the sensor detects vibration. Inside it, we simply increase the state variable by 1 using state++. This tells the main loop that the vibration event has occurred. So in summary, the vibration sensor detects movement, triggers an interrupt, and turns on the LED for half a second while showing the detection status in the serial monitor. That's how our Arduino vibration sensor project works.
As you can see, if we shake the component for a bit, the LED lights up. And that's how we use the tilt switch sensor to light up an LED.